I want you to think about the process of drawing me something. Just the process. You don't know what yet because I haven't told you what to draw. Your drawing mind is empty or full of random noise until I give you the stimuli or prompt to focus your attention on. The minute I do, you will move from random noise to a specific image or parts of a specific image or options of images or an entire creative context pathway. This is diffusion, and the key to generative image AI models begins at the notion of diffusion, or training a machine to create an image from noise or nothing with some cleanup at the end called the nice property, which I will dig into in the labs. The training process in image AI involves the encoding and decoding structure of a transformer to move from original input data to less original and then back again. This was also something I remember in elementary school, or seeing images become defined from noise and attempting to identify the image as soon as possible. And yes, I did have an unusual upbringing compared to today's kids. Okay, upsampling is adding more data between data points. DALL-E uses deconvolution upsampling, which applies a set of filters to steadily increase or improve the resolution and size of the image. It is trained on a database of word-image pairs, but also applies a natural language transformer model/neural net to the word prompts to interpret narrow context, and a CNN for images, and we'll discuss CNNs later in the presentation. The AI also uses an attention-based multimodal fusion, which is combining text and images, etc., i.e. multimodal. It uses both early fusion and a form of late fusion to blend pictures together by filling in the missing parts between the primary images, and it also applies an attention fusion to link image contexts, no matter how bizarre the prompt is. Although it tends to drop or optimize much of the content through general focus, just like we humans do when we get too much stimuli. This last part is just deprecating context by random threshold inflection. That's all. Now, none of this is very complicated if you contemplate the components separately. The text-image pairs are not only curated, or were not only curated, they are human biased in a number of ways. For example, guns. You cannot put guns in the pictures. Usually DALL-E will take that out. You can see this by using DALL-E and watching its response to your queries, especially over multiple runs of the exact same prompt. The anomalous recognition engine in your head should show you the pathways of bias that are fairly evident in DALL-E. This is less apparent in other image AI generators, but it's still there. You can also see the use of a generative adversarial network, where a generator produces images and the discriminator side of the GAN decides if the images are real enough to the target image. And we'll talk about GANs in more detail in a bit, right after we talk about CNNs. In the Dev Bootcamp labs, we play around with some simple GANs, but we will not be doing this in our upcoming Intro Bootcamp lab, so you'll need to attend the Dev Bootcamp to see the mechanics and guts of a GAN. Training images in DALL-E were not created. They were scraped. But copyright is now a growing issue because the source of the image came from somewhere and potentially someone. There was also human supervision infused into the system at some point, and as previously mentioned, human bias. This slide is a bit more detail about DALL-E's training data. We have all contributed to the labeling of images if you have ever used CAPTCHA, or those annoying little images that you have to click on to prove you're not a machine. And there are many other sources, including image posts and descriptions on sites like Instagram, Wikipedia, etc. So it appears that we have all been unpaid interns. Your resume skill line should include the phrase like, Annotated data instances for use in multimodal AI systems at Google as an unpaid intern. Who knew? So this is as far as we will go on DALL-E, but we will look a bit closer at some of these components, and in the investment presentation tomorrow, we'll look at some other innovative image AI systems that are breaking the bias. We'll also talk a bit about NVIDIA GPUs and how image AI systems use some of their rendering tech to fill in the gaps in the output or perform outpainting or extending images like we see in FPS games. More detail about online rendering is in the Artificial Superintelligence Handbook series of books, so enough said. Okay, next let's take a very brief look at Google's stuff. Essentially, it is the same thing with a few twists. BARD is their chat and response AI trained using a large language model tech called Lambda, and a new version large language model tech called PaLM 2. Lambda, or large language model for dialogue application, is Google's answer to ChatGPT's pre-trained generator on a large language model version. And PaLM is another flavor of Google's LLM trained AI that seeks to generalize across different types of stimuli or modes. So this includes elements like world grounding that I've previously written about, and across all uses of this type of stimuli response, so video, etc. Both are trained on the internet, although to a lesser degree than ChatGPT. That's sort of a once bitten, twice shy thing, as Google has already paid the price of trusting raw internet data. But Google has far, far more data on tap with search, Google Books, even my books on AI are in there, and of course CAPTCHA, that little annoying image annotator, etc., YouTube, etc., etc. I'm not going into the detail of this, as it's the same stuff as ChatGPT with Google characteristics. It uses deeper context that is dimensionally longer, i.e. over a longer time, including early inputs, and this helps the conversation flow. Now they have transitioned to PaLM, which is a step toward greater generalization. I mentioned world grounding, which is an attention optimizer to attempt to comprehend relevant context over generalized flowing and variant input. It tightens up the attention is basically what it's doing. And we've done this as well in our lab with something called multi-angulation, which I also won't go into in this particular presentation. Now Google is also seeking multimodality. So the same language foundation can be used for other modes like text to image or video search, etc., etc. They also use a general large language model approach, but can filter to optimize for specific general attention, such as medical or engineering corpi, and country or regime specific censorship requirements like those found in China or Canada, Europe, etc. Now, this is where the idea of world grounding is relevant. Responding to a prompt can produce bad feedback, like turn off the power as fast as possible, to a prompt of what should I do if an electrical cable falls in a pool of water, which ignores the context of avoid stepping in the water first. Now, I've written about the concept of cascading relevant context and multi-flow attention, for example, in ethics and evolutionary seeds, etc., but basically humans assess the world with a situational awareness that AI systems simply don't yet have. BARD is trying to move in this direction by improving artificial self-awareness. As humans, we need a grounding point to contextually anchor a conversation about anything, so we don't spew useless or ridiculous nonsense like bad advice or annoying repetition. Okay, so the same stuff as ChatGPT, so no need to throttle this horse any longer. You get the idea. The important point is that Google has access to far more data and modes of data, video, email, etc., than any other company on Earth. However, they have some severe weaknesses and are facing serious threats, which we will cover in the investment section tomorrow. But next up, I will intro CNNs, RNNs, GANs, and other types of neural networks. This ought to be fun.